I am Suman. Today we will study of class 10 physics, chapter 2, magnetic field of magnetic effect of electric current. This is part 7. And here we will see the two topic, Fleming left hand rule and electric motor. Previous day we have been studied about Fleming right hand rule. Today we will see the Fleming left hand rule and some appliances which is based on this principle. Now, what is Fleming left hand rule? On previous day we have been studied the Fleming right hand rule. So Fleming left hand rule, when we stretch our left hand in such a way that our three fingers are mutually perpendicular to each other, and these fingers are middle finger, index finger and thumb. When these three fingers are mutually perpendicular to each other, and if the middle finger shows the direction of current, then index finger shows the magnetic field and thumb shows the motion, means the movement of the part of the conductors. If the current flow in this direction, the magnetic field is directly perpendicular to the flowing of the direction of the current. Means this index finger shows the magnetic field. Means if the current flow this direction, magnetic field produced in this direction, and the movement or the motion will be this direction, means thumb. So this is Fleming left hand rule. Now there is an instrument which is based on this Fleming right hand rule, and it is electric motor. What is electric motor? Electric motor is a device in which the electrical energy convert into mechanical energy. You have already seen the motors to your homes through which we pump out water, and then water has a capacity to potential energy, and this potential energy, water, when the motor works and it's pump out the water through tube wells, borings, so it's exert potential energy. This potential energy is related to this motor, and the motor is mechanical energy, and this motor works due to electricity, means it has electrical energy. So electrical energy, it convert mechanical energy, and mechanical energy convert into potential energy. So here we will see how the electric motor works. As you are watching here, this is a diagram of this electric motor. It is north and south, as you are watching, north and south. So it is a magnet, horseshoe permanent magnet. A, B, C, D. It is an armature. Armature is a kinds of coil, and a copper wire, insulated copper wire, is wrapped around a soft iron bar. This is axle. This is axle which is connected through this armature. Means armature means it's a kind of coil. So the armature coil connected with axle. And there are two split ring, S1, S2. Split ring means one ring which divide into two parts. This is one ring and it is divided into two parts. It is S1 and S2. Simply you can say split ring or commutator. B1 and B2. B1 and B2 are brushes. It is carbon brushes, because it is actually the allotropes of the carbon, and allotropes of carbon is a good conductor of electricity like graphite. So here B1 and B2 are carbon brushes. So split ring axle, these are connected to the internal circuit, and B1 means carbon brushes B1 and B2 which is connected to the external circuit. Now, we'll study how the electric motor works. As this is the sources of current, means battery, this is switch, and we switch on, the current flow through this direction. Means in coil, the current flow from A to B. The current flow from A to B. Now, as the current flow from A to B, here we'll use the Fleming left hand rule. Now, this is our left hand, and we'll put here in this diagram. This is the direction of current. This is direction of current. As you are watching, the direction of current. So in this diagram, the current is flowing in this direction, and our finger is also in this direction. So this is direction of current. Here, two kinds of magnetic field is working. One is permanent magnet, which is a horseshoe magnet, and you know that we have already studied that in a magnet, the magnetic field produced from North Pole to South Pole externally. So here this is the magnetic field line which flow from North Pole to South Pole externally. As you are watching, this is the direction of current. This is the direction of current. The direction of current is in this direction. So we'll put our name. So this is direction of the current. Now the index finger, this is middle finger, shows the direction of current. Now the index finger, what shows the index finger? Index finger shows the magnetic field. If the current flow in this direction, the magnetic field is inside, means into this board, in this direction. The magnetic field flow in this conductors into the board, means inside. And where is the movement? The movement of this coil. So the movement of this coil is upside direction. Upside means it will come this side. If this is coil, so this coil, the movement, this coil come this side. Now, on the other side of this armature, C to D, as you are watching, the current flow from C to D. The current flow from C to D. Again, we'll use the Fleming left hand rule. So now the current is flowing in this direction. This is the direction of the current, the middle finger, and the index finger indicates the magnetic field which is inside, and the movement is downward direction, means the coil move inside this, means into the board. Suppose that now here this coil upside AB will come upside, and the side of coil CD move downside, and it will complete half rotation. And as this complete half rotation of this armature, the split ring which is connected through axle, it will also move 180 degree, means half a rotation. If the split ring rotates half a rotation, this means S2 will be on S1 place and S1 will be on S2 place. B1 and B2 are displacement. Now the seed point CD will come on a place of AB, and AB will come on place of CD. Again, as you are watching, the AB is outward movement and CD as a inward movement, means coil move this side, this type. Means it will complete half of rotation. So AB, this side AB will come on CD side, and this CD side will come on AB side after completing half rotation. So the direction of current is reversed. The direction of current in CV from C to D, and the direction of current AB is A to B. When this side changes, the direction of current becomes D to C and here B to A. And then it will complete one rotation. And both the side applied the same amount of force because force is depend F equal to BIL. B means magnetic field. This is same magnetic field. I means current. So current is same for both the side AB and CD. And L means length of the conductor. So the length of conductor AB and CD. So length of conductor AB and CD are equal. And this exert this exert a couple force. And then its movement. After half rotation, when it completes, it's become 180 degree. And on 180 degree, as you know that the force is magnetic force is depend on BIL sin theta. And where theta is angle. So 180 degree angle, the value of 180 degree is 0. So total force exerting when it will be 180 degree. So the value of force is 0. Here we will use the Newton's third law of motion. So Newton's first law of motion means law of inertia. What is law of inertia? In a law of inertia, Newton is told if the object is in motion, it will remain in motion, and if the object is at rest, it will remain at rest until and unless an external force not applied. So as this coil start moving, there is no external force applied and the coil is moving continuously, and this is clockwise direction. The coil will move clockwise direction, and this process will continuously again and again, and whatever we want to work from this motor, we can take it. And this is the working and the construction of the electric motor. So till then, thank you. Next day we will study some different motor. It is electric generator, which is based on Fleming right hand rule. Till then, thank you.